Alright, so now we're going to look at the integration and the primitive function and how it relate to finding the exact area under a curve and the x-axis. We're also going to look at areas between the curve and a y-axis as well as part of this topic. We will get there when we cover the skills first. This comes actually straight out of the Maths in Focus text, so some of the thinking style questions before we actually apply them to finding areas. Okay, so there's a link between areas under the curve and the primitive function. Okay, so consider a graph below that shows the speed at which an object travels over time. All right, so we've got second, and we have meters per second. That way. Alright, and the graph is showing us this at 30. And we've got time intervals 1, 2, 3, 4. I should have done that for vertical axis. And 5. What can you tell me about what's happening with the graph? Moving at a constant speed. Alright. So, find the distance that the object travels in 1 second. How far does it travel? Okay, so we're travelling 30 metres per second. So in 1 second, we're going to travel at 30 metres. Alright. B. So t is 1. T equals 2. What is the, not the speed, the distance. Distance travelled in 2 seconds is? Okay, 60 metres, double that, and then C, the T is 3, so after 3 seconds, how far we travelled? 90, so D is 3 lots of 30, which is 90 metres, okay? Now, we need to find the area under the line between these following times. So D, to find the area between T equals 0 and T equals 1. So, what shape am I looking at? Rectangle. A rectangle. Alright, so all we need to do is find the area of the rectangle between t equals 0 and t equals 1. So what is the dimension of the rectangle?
3 by 30. 3 by whatever it is that
30 times by 1.
Shocking.
Oh wait. I thought t equals 4. What am I doing?
What are you doing?
For some reason I thought t equals 4 and t equals 1.
So what's 30 times 1?
30.
30 units squared. Okay, and how far we travelled in 1 second? 30. Alright, so E, T is 0 and T is 2. The area of that rectangle. Okay, so we have the height of 30 and the length of 'okay, and what is the distance covered in 2 seconds? 60. Alright, so we covered 2 metres in 60 seconds. In 2 seconds we've covered 60 metres. So the area of the rectangle between the first 2 seconds is 60 units squared. Alright, now between t is 0 and t is 3. What are we expecting the answer to be? 90. So the area is the same height because we're consistent with the height because it's travelling constant speed, and we've got 3 under here. Okay. So this is obviously the simple way of how they developed that, process of the connection there. Okay, so the graph gives information about what's called a rate of time. Okay, a rate of change. So we are talking about speed. Speed is an example of rate of change because you're talking about the distance covered in some unit of time, okay? We're seeing the relation to speed, how it relates to distance and time. So the area under the curve will give you information about the original data. The original data is called the primitive function, okay? So we've just integrated a function of a rate of change, which is speed. When you integrate the rate of change of speed, we're going to get the distance, okay? When we get some information about the original bits of information, because before we can have speed, we need to know the distance travelled and the time taken. Okay, that's how speed is calculated.